Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good evening. I hope everyone can listen to my voice. Boleh dengar tak? All right, okay, good, nice. So I would like to welcome everybody to our webinar tonight. So the webinar tonight is entitled Integrating Statistical and AI Models for Epidemic Prediction. And this is our Epi Analytics series number 7. And we have our speaker here, Mr. Al Mahmoud. Let me introduce him very quickly. And Al Mahmoud, if you can turn on your video, that would be nice. Al Mahmoud is a master's student in biostatistics at the University of Science Malaysia, where his research focuses on developing hybrid ARIMA and LSTM models for COVID-19, time series forecasting. He holds a bachelor's degree in statistics from Shah Jalal University of Science and Technology, Bangladesh, and his research interests include biostatistics, AI in health, mental health epidemiology, and time series modeling. He has authored and co-authored several peer-reviewed publications on topics such as depression, mental health among adolescents, and advanced forecasting techniques for COVID-19. His work has been presented at international conferences in Malaysia, Singapore, and Bangladesh. He's also the recipient of the FRGS grant from the Ministry of Higher Education, Malaysia. With a strong background in quantitative research and public health, Mahmoud aims to contribute to improving health decision making through data-driven approaches. We have altogether 56 participants. If you have questions, you can ask in the chat box, or you can raise your hand, and I can allow you to ask the questions direct to Al Mahmoud. I think if Al Mahmoud is ready, then I would like to call upon Mr. Al Mahmoud to present the webinar tonight with the title Integrating Statistical and AI Models for Epidemic Prediction. We can't hear you, I think. Anybody can listen to Al Mahmoud? Yeah, we can't hear you. We can't hear you. All right, let us wait for a while Al Mahmoud fix his audio setting.
Sorry, doctor. Now, do you hearing me?
Yes, now we can hear you. Right.
Sorry, actually, my microphone is not working, I think.
All right. And let me, because I think you have two account, right? So let me just a second, yeah? All right. Okay, all right. Mr. Al Mahmoud, if you are ready, I think you can share your slide. So we have until 9 49:35, then we will allow for question answer session. So thank you for uh, for for you know uh, for the opportunity to listen to your talk. So the floor is yours, Al Mahmoud.
Doctor, can you see my slide screen?
Yes, we can see your slide. Yes, we can see your slide, and we can also listen to your voice.
Okay, thank you, Doctor. Assalamu alaikum and good evening, everyone. I am Al Mahmoud, currently pursuing my master's degree in biostatistics at University of Science Malaysia. It is truly an honor to be the speaker for today's session in the EP Analytics Series 7. Titled Integrating Statistical and Artificial Intelligence Model for Epidemic Forecasting and ARIMA LSTM case study in Malaysia. At first, I would like to express my sincere appreciation to the Digital Health Unit, School of Medical Science, University of Science Malaysia, the Malaysian Association of Epidemiology, and Persatuan Anggota Kesihatan Kelantan for organizing this webinar. I also wish to extend my gratitude to our moderator, Professor Dr. Kamarul Musa, for his guidance and support. In today's session, I will be sharing insight into how statistical models such as ARIMA can be integrated with artificial intelligence, AI technique like LSTM, and hybrid model to enhance forecasting accuracy. We will explore how this model complement each other and how they can support better decision making in public health. I hope this session provide valuable knowledge and spark new idea for both research and practice. All right, let's start our main session. I am Al Mahmoud, and I am currently pursuing master's degree in biostatistics at University of Science Malaysia. My research focus on time series forecasting and machine learning models, particularly hybrid approaches such as ARIMA LSTM for improving COVID-19 prediction and decision making. And my supervisor name is Dr. Muhammad Arif bin Wan Nawi. I completed bachelor degree in statistics at Shahjahan University of Science and Technology, Bangladesh. My research explains diverse areas, including mental health, malnutrition, diabetics, and ethnic health disability in Bangladesh. Behind research, I'm passionate about leveraging statistical machine learning model and addressing facing public health challenges. I'm eager to advance my expertise through PhD research, intercollaboration, and impactful publication. Reminding that reminding our title, integrating statistical and AI model, epidemic forecasting and ARIMA LSTM case study in Malaysia. How to define a statistical model? A statistical model is a mathematical framework that represents the using probability theory and statistical assumption. It explains the relationship between variables through equation and is often used for inference and forecasting. For example, ARIMA model. ARIMA model, the full form is auto-regressive integrated moving average. It has three parameters. Three parameters are P, D, Q. P for auto-regressive, D for integrated or differentiation, and Q for moving average. The purpose of this model, this relationship, linear relationship in time series forecasting. For example, days and autocorrelation. The advantage of the ARIMA model is short-term forecasting and stationary data. And it has also disadvantage. It cannot be handling seasonality directly. Our next model is Sharima model. Sharima is called extension of ARIMA model. It captures seasonal pattern, for example, weekly data, monthly and yearly data. It advantages data with repeating seasonal trends. And next one is Sharimex model. It also called extension of Sharima model. Seasonal arima model with exogenous variable is called Sharimex model. It including extension factor that may influence the series. The advantage of Sharimex model for time series influenced by outside drivers. For example, predicting COVID-19 cases using data as extra variables. And next one is GARCS model, generalized auto-regressive conditional heteroscedasticity model. It mainly focuses on modeling volatility or variance over the time. It commonly uses financial, economic data, for example, stock market, exchange rate, etc. The advantage of this model, data with fluctuating variance. And last one is ETS model, exponential smoothing models. Basically, it used for weighted average of past data, while recent data has more weighted. It commonly captures the trends and seasonality data. For summary of the example, Arima model basic forecasting backbone, Sharima model add seasonality, and Sharimax model add extensional influences. GRS model capture change in volatility, and lastly, ETS model just simple smoothing based approach. Next one is artificial intelligence model, AI model. An artificial intelligence model is computational system that learn pattern from data using machine learning and deep learning algorithm. Instead of relying to stick assumption, it adapts automatically to capture both linear and nonlinear relationship in the data. For example, ANN model, artificial neural network model. It inspired by the human brain, neuron, and pattern out and pattern adjusting weighted and between weighted and norms. The advantage of this model, it capturing non-linear relationship, and it also has this disadvantage. It don't handling time dependency as well. And next one is RNN model, neural network model. A type of neural network designed for sequential data or time series. The advantage in model, the short-term dependency in time series, and it has also disadvantage for struggling with long-term memory. And next one is LSTM model, long short-term memory. It advanced for RNN model. And the benefit of this model, long time series data forecasting, for example, epidemic data, climate change data, etc. And last one, GRE model, gated recurrent unit. Similar to the LSTM model, but is smaller or fewer gated to LSTM model. If you want to see the internal architect of LSTM model, is LSTM model is more complexity, but GRE model is not more complexity, it's simple. Now, hybrid model or integrated model. How to define hybrid model? A hybrid model is forecasting approach that integrated a statistical model and artificial intelligence model to capture both linear and nonlinear pattern in time series data. The statistical model explains structure and linear component, while the AI model learns complexity, nonlinear relationship. By combining this model is called hybrid model. What is the benefit of this model? This benefit is improved accuracy, robustness, and reliability compared to using individual model. Now, how to generate the hybrid model? First, we want to fit ARIMA model. In the first step, we use ARIMA to model the linear part of the data. This gives the baseline prediction, but it cannot be fully captured nonlinear pattern like certain changes. After fitting a model, we check it residual. These are error between actual and predicted values. The residual represent the nonlinear part that ARIMA cannot capture. These will be used as input for the LSTM model. The third step is train LSTM model. We train the LSTM on ARIMA's residual. LSTM is powerful and reorganizing nonlinear relation and pattern on over time. It helps correct ARIMA's shortcomings. And finally, we develop hybrid forecast. We combine the output from both models and ARIMA forecasting handle and linear trends and LSTM correctly nonlinear adjusted. The fusion of this make hybrid model is more accurate and stable. Why use hybrid model? The significance of hybrid. Firstly, capture both linear and nonlinear pattern. How to linear and nonlinear pattern capturing? ARIMA model, I said before, ARIMA model handling the linear pattern and LSTM model handling the nonlinear pattern. That's why both capture linear and nonlinear. And secondly, reduce forecasting error by combining hybrid model, produce lower error metrics. For example, mean absolute error, root means square error, etc. That means is more accurate predictive forecasting. And thirdly, balance interpretability and powerful. ARIMA gives interpretable coefficient and LSTM gives the flexibility of the model. The combined is model both understandable and powerful. And thirdly, practical in epidemic forecasting. We use ARIMA, we use this model with COVID-19 cases. COVID-19 data is a practical data in the world. It helps to policymakers in short and medium term to planning. For example, planning to lockdown, ICU capacity, and etc. And generalizable to others fielded. Hybrid model not only use the ARIMA, not only use the COVID-19 cases, it also use others fielded. For example, finance, energy demand, climate change, healthcare. This is the problem statement. The ARIMA model have two mainly problems. ARIMA model contained by linear assumption and its error variance is constant. While the LSTM model also gives the bold prediction. This is our problem statement of study. Research question. Now, we have three research questions here. How do hybrid models enhance the accuracy of COVID-19 prediction compared to individual ARIMA and LSTM model? Second one, hybrid model improve the efficiency of time series forecasting COVID-19 cases. And last one, how the overall performance of hybrid model against individual LSTM and ARIMA models. And this is a specific objective. First objective was to develop the hybrid model for time series forecasting in COVID-19 cases. Second one, to investigate the model's accuracy and efficiency in predicting COVID-19 trends. And finally, to compare the performance on those models in real world COVID-19 data. After completing the background, we will discuss methodology part. First of all, study population. COVID-19 data were obtained from Malaysian Ministry of Health Education website, covering daily confirmed cases, recovery cases, and death cases, January 4 to September 18, 2021. This is our study procedure. We have three phases in whole study. First phases have also three subphases. First phases was preparing data series, preparing time series data, and phases selection. It has three subphases. Firstly, convert data into time series. Secondly, normalize the data. And thirdly, split time series data. After complete the first phase, we'll go to second phase. Basically, we have two models. First model, baseline model, for example, ARIMA and LST model. And second model is proposed model, hybrid model. After combining this model, we optimize, train, and evaluated those models. And after complete the phase 2, we'll go to the phase 3 for applying how to predict model. Baseline model and proposed model combining the prediction and evaluation those models. This slide was split time series data set. COVID-19 data set is split with forecasting period. Our data set was January 4, 2021 to 18 September 2021. Here we split four phases, four periods. First period is training period. This represents the sky blue, sky color. The duration of the training period was 4 January to 2 July. And second period was validation. The duration of validation period 3 July to 10 August. And thirdly, testing period. The duration of testing period was 11 August to 18 September, and finally forecasting period. That was 12 September to 18 September 2021. This is the split of times this period. Now statistical test. This slide shows the result of the Daybold-Mariano test or DM test, which is used to statistically compare the forecasting accuracy between models. As we can see, the ARIMA versus LSTM model, it has p-value 0.42. That means it's greater than 0.05, meaning there is no statistical significance between ARIMA and LSTM model. And others there, ARIMA versus hybrid model, if p-value has 0.09, it marginal significance. And finally, the red color represents the ARIMA and hybrid models. His p-value is 0.02. That means it's less than 0.05. It is statistically significant. That means the hybrid model performs statistically better than traditional ARIMA models. Overall, this test confirmed that integrating ARIMA with LSTM improved forecasting performance. Sorry. Okay, now this is validation process. In this slide, I am sharing these validation metrics that were used to evaluate model performance. To ensure our forecasts are accurate and reliable, to use several common metrics. For example, MSE, mean square error. It measures the average square difference between actual and predicted cases. And another one, MAE, mean absolute error. It gives the average absolute difference, reminding it smaller MAE means better accuracy. And other one is R square, the coefficient of determination. It's showing that how much the model is explained to the variation. Both together, these metrics give a comprehensive view of how well is model performance and help us identify its forecasting method is the best. This slide is parameter. ARIMA and LSTM parameters we used our study. I said before, ARIMA have three parameters like P, D, Q. P for autoregressive order, D for differentiating or integrated, and Q for moving average term. The range of P value 0 to 9, the best range was selected 7, and others. The range of D value is 0 to 9, and best range is 4. And Q range 0 to 9, also best value is 6. Similarly, to LSTM models, it have 4 parameters. To mention here, number of unit of LSTM layer, number of epochs, batch size, and sequence length. The number of layer 100 to 400, the best value 200, and the number of epoch size, also the range 100 to 400, its best value is 200. The best size, the range 4 to 2022, the best was 16. And lastly, sequence length 0, 1, the best one is 1. This slide is symmetry of hybrid model architecture. This is the time series to final model, first time series data, and generate the ARIMA model. After ARIMA model, residual, and calculating residual and LSTM by combining, we generated the final forecast model. This is the symmetric hybrid model for architecture. And that was the study flowchart. After calculating the COVID-19 data preprocessing in COVID-19. How to data preprocessing? There are 2 steps here: preparing time series data and feature selection. After feature selection, we building the predictive model. Firstly, we created ARIMA model and LSTM model and hybrid model. After combining these, the evaluation and forecasting based on the validation metrics for MAE, mean absolute percentage error, mean absolute error, root means absolute error, etc. And after validation process, then we will publish, writing and publishes. That is the study flowchart. And we mentioned here some algorithm for use ARIMA model and ARIMA, LSTM, and hybrid models. We mentioned here 4 columns. First, ARIMA, LSTM, hybrid, evaluation metrics, and data preprocessing. Secondly, implementation. For ARIMA model, implementation Python, state models. Why use this model? For example, used to capturing linear dependency in time series data. For LSTM model, implementation Python, TensorFlow, and Keras. Purpose, the nonlinear dependency data. And hybrid model, implementation, TensorFlow, Keras, and state model. Combining ARIMA, linear and nonlinear models, LSTM models. And models for evaluation metrics, we use implementation Python, scikit-learn to calculating the performance metrics such as mean square error, mean absolute error, and all error term with R-squared values. And finally, models data preprocessing. We use Python and data preprocessing, preparing the dataset, the model training, and normalizing split the data. That was the algorithm and model we used developing this hybrid model. After methodology, we will go to the result section. In this result section, they represent the model performance comparison for forecasting COVID-19 active cases. As shows the table, we compare 3 models with ARIMA, LSTM, and hybrid models. For hybrid model, achieve the lowest error both ARIMA and LSTM model. Specifically, for example, MSE, mean square error, is less than anima values, RMSE, MAE also both. Specifically, the MAPE for hybrid model is 6.4%, 43%, is lower than ARIMA 6.55% and LSTM 8.09%. And the coefficient of determination R square value is greater than hybrid model with compared to ARIMA and LSTM model. Hybrid model was 30% and LSTM model was 20% and ARIMA model 29%. That is the hybrid model is biggest value for R square value. Overall, the hybrid models demonstrate the best performance of active cases in result section. Similarly, two recovery cases have shown the similar result. For mean absolute percentage error shows that hybrid model 8.06%, LSTM model 11.35%, and ARIMA model 8.07%. For R squared, coefficient of determination also 21% for hybrid model, LSTM model minus 90% almost, and ARIMA model 20%. That one, the hybrid model is the best performance of recovery cases. And we compare to dead cases. Also similar those result, the MAPE mean absolute percentage error 15.28% and LSTM model 42.06% and ARIMA model 14.39%. Although LSTM model is better, but their R square value is not positive value. That's why we can say the R square value of hybrid model 47% and ARIMA model 45%. That's why we consider that the dead cases also hybrid model is better performance than others two models. And we see the forecasting value with both dead cases, active cases, and recovery cases. Now let's look at the forecasting result active cases for first graph. The figure compared to the actual cases shows by black line is bold black line is the actual cases value, and upper side is blue line is represent the for ARIMA forecast, and middle red line represent the LSTM, and the green line represent the hybrid model. We can see easily that the hybrid model is better perform and better accuracy for active cases. And we can see the recovery case in the same process. The black line represent the actual values, and green line represent the ARIMA case forecasting value, and red line represent the LSTM forecasting value. That's why we clearly see that the hybrid model is also better performance than others two models, individual models. In summary of in dead cases also similar. In summary of the study, we can say ARIMA fluctuate for active cases and recovery cases, dead cases also. And LSTM overestimate all cases. But hybrid model is close to the actual cases. We conclude that this result, the hybrid models, their forecasting value is close to the actual values. Now, after discussion, after result, we will discuss the discussion part. The hybrid model gives more accurate forecasting than using individual or only LSTM and ARIMA model. That means it predicts future cases more closely to the real numbers. And another study shows that ARIMA, GRU, LSTM, Prophet, and ARIMA in hybrid models is not better or is not equal to hybrid LSTM model. It shows that the hybrid LSTM model is better performance. They use the three error metrics. For example, MAPE, symmetric means absolute percentage error, and median absolute error. They shows that hybrid LSTM model is better performance to those individual model. And another analysis to forecasting model like dot forecasting in Chinese. The hybrid LSTM model is enhanced dot forecasting in China using SPEI compared to 5 others models. Also, they got positive value for hybrid model, highest accuracy. They got highest accuracy. And others study combining three individual model. For example, LSTM, ERIMA, LSTM, and XGBoost. Combining three models for accurate transfer well temperature prediction. They got the lower error values. For example, MSE 99%, 0.99%, and mean absolute percentage error 1.98%, and their accuracy got 69%. And we received others study from Malaysia. They use COVID-19 mortality rate in Malaysia among. They only test for ERIMA model, but like this, just change the parameter 113, 114. The combining is 114 is better, but we use to others parameters. For example, P7, 4, 3, like etc. This study preliminary framework and forecasting mortality trends in future prediction. Each and every study has some limitation, but also some limitation here. The study focused only the three forecasting model without including alternative hybrid. For example, we use only for hybrid ERIMA LSTM model, but we don't use ERIMA JRE model, ERIMA profit model. This is the limitation of our study. And secondly, we train our data set only one time, single time, for train, validation, and test. That means it may introduce bias or increasing the overfitting. This is the limitation of our study. And thirdly, our data set variable number is limited. For example, the scope and size is limitation. How we said before, our data set was 4 January 2021 to 18 September 2021. If we want to base robustness, if we try others data set, for example, 2 years or 3 year long data, then we can estimate the prediction value is better accuracy. I think this is our limitation of this study. Future work of this study. Explore alternative hybrid model for forecasting model. For example, we will explore later the Bayesian method or exponential smoothing to improve prediction, and pre-processing technique like external variable. For example, if we want to add the exogenous variable like vaccine rate, weather, population density, and etc. for the accuracy and reliability of this study. And conclusion. Our hybrid models to give more accurate performance in a single models. It combines the statistical ERIMA and artificial intelligence LSTM model. It helps to outbreak prediction and better public health planning. And lastly, hybrid approach can guide the future epidemic forecasting system. If you want to more details, this is our latest published article. Just scan and read if you know more. research project is still in progress. Actually, we are doing now hybrid ARIMA project, ARIMA Prophet, hybrid LSTM exposed, hybrid ARIMA GRU, hybrid ARIMA Sphere, all combination of the individual model to get better result with exogenous variable. For example, vaccine rate, rainfall, and population density, temperature, etc. etc. This part is not in ongoing study, and we will share in later time, inshallah.
All right. Yeah. Anything else?
Actually, this study was carried out my humble effort and under my guidance of my supervisor. If any correction or area for improvement, I would be happy to receive your feedback. And I also discuss with my supervisor later. Thank you for everyone. Thank you for attention. Thank you.
Brilliant, brilliant. So, thank you, Al Mahmoud. I think that is very interesting study where you have time series data, and usually we use ARIMA models, right, to make forecast, to make forecasting, and now you have um, LSTM, and you hybrid the two, LSTM ARIMA, to make to make a better for forecasting. So my questions, if you have any, if any participant have questions, you can unmute yourself, or you can raise your hand. Um, I will allow you to ask questions, or you can type in the chat box. But while waiting for people to ask questions, Thiru Murugan from UMS asked, is there an automated retraining process to maintain predictive accuracy? I'm not so sure what Thiru means, but Al Mahmoud, any response to that?
Yes, doctor. We use actually automatic ARIMA, only just ARIMA model, not hybrid. We find out the automatic ARIMA to select the parameter. Like we have it ARIMA model has three parameters. For example, P, D, Q. We don't identify which values those better parameter, better model. But here we select previously. That's why we select previously automatic ARIMA based on the better performance. For example, lowest error term and highest accuracy. This is the use automatic for only ARIMA model, not only for LSTM and hybrid.
Right, thank you. I want to ask, do you consider LSTM as a deep learning model, Al Mahmoud? And whether, whether if you have, whether how long and how long does it take to train to your model?
For this slide, actually, doctor.
Right. So my question is LSTM a deep learning model, or is just a one layer machine learning model, or is it a deep learning multi-layer model?
Actually, doctor, we use the Python code for multi-layer model.
Right.
Not only this one single layer. We use like ARIMA, the LSTM model. Like we select more than 200, and we select the range like 200 to 400, and they provide the 200 layer is better for LSTM models.
Right.
Get model, yes.
How long does it take to run the analysis? How many minutes?
How many minutes to take run? Actually, doctor, is not only maybe it's 2 or 3 minutes.
Okay, that's quite fast. All right. Okay.
Yes, that's quite fast.
My next question. Do you don't need NVIDIA or GPU to run hybrid model, right? It's enough with
Yes,
CPU.
Doctor, we don't use this. We don't use. Yes.
Right. My last question would be: Do you have your codes available on GitHub for people to refer to if they are interested to run their model
Yes.
as well?
Yes, Doctor. We already linked our published article GitHub. We said all coded and this all code like ARIMA, LSTM, and hybrid model. If you want to interest us, I will share link in show.
All right. So let me see if I can, if anyone wants to ask any more questions. I think Dr. Arifin just now unmute. Dr. Wanu Arifin, want to ask question?
Okay, thank you for just want to ask few questions. In your study, why did you consider on the ARIMA and LSTM as the baseline models or the benchmark model? Because in this kind of study, usually people would compare the newly tested hybrid model, for example, with some of the classical models. Maybe, for example, I would expect that you actually test it against ARIMA, SARIMA, SARIMAX, and so on. Did you consider that when you run the experiment?
Doctor, we just use ARIMA model because we have no other exogenous variable. For example, the vaccination rate or population density or whether if we get exogenous variable, we will run those ARIMA and SARIMAX model later time, inshallah.
Next question, Dr. Wan Arifin. Are there more questions?
And another thing, if you look at the error rates, okay, I noticed that the error rate between LSTM, the hybrid model is not that.
Sorry, doctor.
The error rate for LSTM was quite high. Can you explain why it happened to be that way? For example, MAP, right? Okay, you look at the MAP. Okay, MAP for ARIMA is only 6.5 and 6.4, not much different, right? But LSTM is markedly different from the other two, 8.09. Okay, can you, is there any explanation why the error rate for LSTM alone is quite high?
Doctor, actually, this is, I don't know actually why this result shows. I think I will explain, I explained already the ARIMA models and LSTM model and hybrid model. But each and every cases, ARIMA models, hybrid model is better accuracy and better performance.
Yeah, but if you look at
yes.
But if you look at the difference, it's quite a very small difference, 0.1. Like for example, another one R square, if you just round it up, both will be 0.21. Okay, so
Yes,
for me, not that much different. Okay. And I suspect, the reason being that because your hybrid model actually rely on the residual from ARIMA. So maybe something you can look into later, maybe. Something because I suspect that would be the case, and that's why the improvement is not that much.
Yes, doctor, your observation is correct. This improvement is not higher than. That's why we test the DM test. For example, ARIMA versus LSTM model is not significant because their ARIMA and LSTM models are similar for our study. But ARIMA and hybrid model is statistically significant for their difference. For example, p value here 0.02 is that means less than 0.05. ARIMA it shows the little difference, but it's statistically difference. If we want to see is recovery cases, active cases, and death cases, all every cases, hybrid model is better. How to hybrid model is better, and we identify the statistical test. The statistical test shows that ARIMA ARIMA and hybrid model is statistically different, although their value is little bit different. Okay, doctor?
For me, I would caution against using this too much reliant on statistical tests to prove that your model is better. Maybe you should rely on, because there are several, you listed down so many performance metrics, right? I would suggest that you because your study is still not finished, right? Maybe you should rely more on all these performance metrics instead of relying too much on the significant test. Because to my experience, usually statistical tests in this kind of study is actually not that really useful. Maybe, right? It gives you some false positive test, be right? But I would rather rely on all these performance matrices. We should be we should inform us, give more information as compared to just plain statistical test. It's just p-value, right? It don't tell us the magnitude of the differences between the methods. Okay. I think that's all from me, Apa.
All right,
Yes,
all right.
Actually, Doctor, this project ongoing. We will we'll analyze this hybrid for 2 or 3 individual combined to the lackings of this study performance.
Right.
Inshallah.
Brilliant, brilliant. So I think what I can conclude is let me share. Okay. Right. So I think I would like to say thanks Al Mahmoud for your presentation. I think what I can get from today's presentation is that you have previously ARIMA models, right? That you look at the trends, and then when you have time series data, then you think of, okay, should I do exponential smoothing or should I do ARIMA model, right? So now you have LSTM as well, and on top of that, you also have a hybrid LSTM plus ARIMA, right? So that's I think open up a few more models for you, right? Which I think interesting. But again, so I think for my fellow friends, my students, this is a method that I think you should be thinking of doing, because we have lots of time series data, mortality data, incidence data. So think of ARIMA, think of LSTML also, and why not do a hybrid approach as well? I was looking at packages in R, whether R also have, similar or have capabilities to run hybrid model. But unfortunately, you showed to us they are all in Python. So very quick comment whether whether are there available packages in R to run hybrid model.
I cannot hear you.
Yes, Doctor. We will run again to our package, inshallah. I will discuss my supervisor to
All right. Okay.
Okay, Prof. Another suggestion. Maybe Al Mahmoud can write the package for us. I think for him, as because his background is mathematics, I don't think that would be too difficult. Quite easy. Okay. Just
Right.
right.
Right. So Dr. Arifin proposed that you write an art package, So yeah, I look forward to that package. So I guess that's all for tonight. I would like to say thank you very much. I'm Kamaru Imran Musa, your moderator tonight. I would like to say thank you very much to all the participants tonight. And thank you to Digital Health Unit, the Persatuan Anggota Kesihatan Kelantan, the Malaysian Association of Epidemiology. If you have not registered with this association, please do so, so we can, keep sharing knowledge and skills and whatnot. Thank you again to Al Mahmud. We pray that you complete your PhD as soon as possible. So and we will make this recording available on Unique Kesihatan Digital YouTube channel. So thank you very much. Have a good weekend for those in Kelantan, Terengganu, and Kedah. And so that's all. Assalamualaikum.
Waalaikumsalam, Dr. Thank you so much, Keith.
Thank you, Al Mahmud, for your presentation tonight. Send my regards to your supervisor, Dr. Arif.